The second part of the 5.6 introduction is focused on the properties of exponents. So I went ahead and I put all of the properties on exponents over on this side, and I'm going to walk you through the examples on this side. Normally when we do this, we just have whole numbers in the numerator, so I changed it up and I put fractions. I challenge you to not use your calculator when we're dealing with the fractions and try doing it by hand, because some of you can really benefit from this practice. Okay, the first property we have is right here. It says that when we multiply two terms together that have the same base, we can add the exponents. So when we multiply, we add the exponents. Take a look at example 1. Both have a base of 3, so when I multiply these together, I can add the exponents. This is 3 to the 1/2 plus 3/2 power. Now when we add and subtract fractions, we need to make sure we have a common denominator, which we do in this case. So I can go ahead and add. This becomes 1 plus 3, so 4 over our common denominator of 2. Or this is 3 squared, making my answer 9. Scooch it over a little bit. The second property is referred to as the power to power property. Whenever you have a power raised to a power, we multiply those exponents. So over here, I have a power to a power. So really what I have is 4 to the 3/2 times 2. Or I can rewrite this as 2 over 1 if I like. Because remember, when you multiply, you go across the top, across the bottom. I just want to make sure you understand that this 2 is in the numerator position. So 3 times 2, which is 6 over 2. So 6 over 2 is 3. Or you could have canceled out the 2's, which gives you 4 cubed. Now remember, 4 cubed is 4 times 4 times 4. So 4 times 4 is 16, times 4 is 64. Okay, number 3, we have two different terms, so different bases raised to the same power. When we have that, we can distribute the power to both of those terms. Take a look at example 3. We have a 9 and an x squared. These are different bases. I have a base of 9 here and a base of x here. So I need to distribute that power of 1/2 to both. So I get 9 to the 1/2 power and then x squared to the 1/2 power. I believe I mentioned this before, and this is going to be a great review for 5.6, but I want you to add a little note up here. Something to the 1/2 power is equivalent to the square root of that something. So the 1/2 power is equivalent to taking the square root. I say that because if I look here, 9 to the 1/2 power, that's the same thing as saying the square root of 9, which we know how to evaluate. We just did that on the front page of this. And then over here, I have x squared to the 1/2 power. So there's two ways you could do this. You could take the square root of x squared, in which case they're inverse functions, so they'd cancel each other out, leaving me with x. Or you could also see that this is a power to a power, like number 2. So 2 times 1/2 is 1. So it's just x to the first power. And the square root of 9 was 3. So really, this is 3 times x. If that confused you, no worries. We're going to practice more with this in 5.6. This is just an introduction. Number 4 is a reminder of negative exponents. So when you have a negative exponent, we move it. If it's in the numerator position already and it's negative, we move it down to the denominator. If I had something like this, 1 over a to the negative m. So if it starts off in the denominator, we would move it up to the numerator. Okay? So it's just the act of moving it. Okay, that being said, example 4. We have 25 to the negative 1/2 power. I first need to move it from the numerator's position to the denominator. So it just becomes 25 to the 1/2 power. That act of moving it has now made the exponent positive. And remember, I just said that when it's x to the 1/2 power, it's equivalent to the square root. So this is 25 to the 1/2 power. So that's equivalent to 1 over the square root of 25, or 1/5. Next, we have the quotient property for exponents, which just says that when we have the same base and we are dividing, we can subtract the exponents. Take a look at example 5. We have the same base, so I can go ahead and subtract. This will be 6 to the 5/2 minus 1/2 power. It already has a common denominator. I won't always be so nice, but for now, I will. So I can go ahead and subtract. This becomes 6 to the 5 minus 1, which is 4 over 2, or 6 squared, or 36. All right, lastly, we have 2 different bases being raised to a power. We saw this before with number 3. We had 2 different bases being multiplied, raised to a power, and we just distributed. We're going to do the same thing with 6. We have 2 different bases to a power. We're just going to distribute that power. So over here, I have 8 to the 1/3 and 27 to the 1/3. Now, if the 1/2 power is the square root, then what would the 1/3 power be? So we're going to make another note. X to the 1/3 power is going to be equivalent to the cube root. Again, this is an idea you're going to see more in 5.6. So now I really have the cube root of 8 over the cube root of 27. So I just need to ask myself, what cubed would give me 8? The answer is 2. What cubed would give me 27? Well, 3. So the answer is 2/3. Just a little side note, I'm going to show you how to plug this in your calculator. So we know if I wanted to say, oh, well, what's the square root of, I don't know, 25? That's a perfect square. We could hit second, and then that squared button gives me the square root, and 25. Plug it in. Boom. There you go. So that is what we do for the square root. If you have something like the cube root, which is what we were just doing over here, so let's say I wanted to plug in the cube root of 8. The first thing you're going to have to do is plug in the index. So that's the number on the outside of the root. Okay, so that's going to be a 3. And then instead of hitting the second squared to give me the square root, I need to hit the second and then that little caret, that power sign. And I now have a cubed root of 8. You'll see I get 2. Let's try that again. Cube root, I put the 3 first, and then second power, I now have the cubed root of 27. You can see how I get 3. We're going to work more with that as we continue the 5.6 notes. But for now, why don't you go ahead and try the homework?